Welcome to Chemical Reactions Explained, hosted by Trinity Krigswold, Period 2. The first reaction we're going to be looking at today is synthesis. In this reaction, we start with two elements. For simplicity, we're going to call them A and B. And once bonded, these elements yield AB, which represents one compound unit. We're going to go ahead and combine our A and B to get our yield. Now let's go ahead and add some actual elements to our formula. We're going to start with our A, representing carbon, and our B, representing our oxygen gas. And we'll add our AB in there, which is representing our carbon dioxide, or in other words, our final yield. So we can see right here where our carbon starts, and we can see right where it ends up. So I'll go ahead and put our carbon, and we can see right where our oxygen gas starts and right where it ends up. So I'll go ahead and put our oxygen gas in there. The next reaction we're going to be talking about is very similar to synthesis, and it is decomposition. So our formula for this is actually the same formula for synthesis backwards. So instead of ending with our AB compound, we're actually starting with it and we're breaking it down or decomposing it. So for this example, I have this ramen, and this is our whole compound, the whole package of ramen altogether. And when we break it down, decompose it, we actually get our A, which is the noodles, and our B, which is the packaging. Okay, so now we can go ahead and add some real elements to our formula. And I'm not going to put these back together, but just for example's sake, we'll go ahead and have that right there. Yes, okay, so our AB is representing calcium carbonate, starting right over here, our compound, our AB compound, and we're going to decompose and break that up into our two parts, the calcium oxide and the carbon dioxide. So just as simple as pulling apart our two pieces, we get the wrapper separated, we get the noodles separated, and now we have our calcium oxide and we have our carbon dioxide, and that's our yield. For our next reaction, we're going to be talking about single displacement. So just like the reactions we talked about previously, we have a AB compound involved, but this time we have a third little lonely element. So we have our two combined elements, and then we have our third one off to the side all by itself. And the goal of single displacement is to take that third element and switch it with one of these two, get it in the compound. As you can see in our yield, one of these elements is going to be by itself no matter what. What we're wondering is, how do we determine which one is going to stay in the compound between these two and which one is going to end up by itself? So here, if we look closely, put to the center, you can see that I have labeled these elements with either a green plus or a red minus. So the red minus represents the element being negatively charged or being an anion, and the green plus represents it being positively charged or being a cation. So our rule in chemistry is you can only pair a positive and a negative together. A negative and a negative cannot be paired, a positive and a positive cannot be paired. So how do we determine which is which? And for the sake of this example, I just went ahead and said that our C element is an anion because it's not a real element and it can be whatever I want it to be. So that means that we would swap our negatively charged element with our other negatively charged element, so we keep the balance between positive and negative in our compound. So now that we're starting to grasp the concept of this formula, let's go ahead and add some real elements in there. So we're starting off with our copper 2 chloride, which is being represented by AB compound, and our zinc, which is all by itself, represented by this lonely little drill bit. And what we're going to do with our elements is we're going to break these two up, and we're going to take this guy. It's hard to write on this. Take this guy, I'm going to put him in here. We're going to take this guy, bring him out there, which explains our yield, explains our zinc chloride, and our copper all by its lonesome. So let's go ahead and do the visual of that. So we're going to go ahead and take our copper out of our AB compound, and it's going to go to the side by itself. We're going to take our zinc and put it in our compound, making it an AC compound, or in more technical terms, making our zinc chloride compound come together. And now, just like in our yield, our copper is all by itself. So this next reaction is very similar to the single replacement reaction. However, this time we're going to be swapping 2 elements instead of just 1, hence the name double. And for this example, we're going to be swapping some pens around. So here you can see I have our compound, AB compound, and our CD compound. And if I pull them apart, then I just have A and I just have B. When I put them together, it makes them a compound. So, no, please stay up. Okay, well that one's just going to be down. So our rule about the charge of the elements still applies here, meaning that we cannot swap B and C. As you can see up here, B has a negative charge and C has positive charge. And we cannot flip-flop them because that would make C and A together and they both have positive, and B and D together and they both have negative, and that just doesn't work. Because if I were to put A and C together, they do not bond. B and D, they do not bond. So instead, you're going to stick to our rule, and we're going to pick either cations or anions to swap. It doesn't matter which ones we swap. For the sake of this video, I'm going to pick our anions, and we're just going to swap them around. Make a new compound. Now we have AD, we have CB. So now we can go ahead and throw in some real elements into our formula. So representing our sodium sulfide, we have AB. And representing our hydrogen chloride, we have our CD compound. So as you can see here, we have our little plus sign for our cations and our negative sign for our anions. So we're just going to go ahead and take our anion A, representing sodium, and we're going to take our cation C, representing hydrogen, and we're just going to flip-flop them. And that leaves us with our new compounds, AD and CB, which are representing, I cannot get these to stand up, which are representing sodium chloride and hydrogen sulfide over here. And to finish it off, we do have to balance our equation. I don't have another pen, so I'll use this pink one. We're just gonna add 2 there and a 2 there, and boom, we're done. Our total yield is finished. Our last reaction we're going to talk about is combustion. So a combustion reaction is usually any reaction that causes something to burn, it always involves oxygen gas, and when organic molecules combust, they yield H2O and carbon dioxide. So for our example, we're going to be grilling these cucumbers and putting a cover over it so that we can see the condensation.